We now discuss the solution of a problem from the section three-dimensional geometry, and this question is related to the angle between the given planes. This question has appeared in the joint entrance examination main held on 28th June 2022 in the morning shift, that is shift 1. The given question is the acute angle between the planes P1 and P2 when P1 and P2 are the planes passing through the intersection of the planes 5x plus 8y plus 13z minus 29 is equal to 0 and 8x minus 7y plus z minus 20 is equal to 0. And the points 2, 1, 3 and 0, 1, 2 respectively is, we are given 4 options, option A pi by 3, option B pi by 4, option C pi by 6, option D pi by 12. Now we are given 2 planes. The first plane is 5x plus 8y plus 13z minus 29 is equal to 0 and the second plane is 8x minus 7y plus z minus 20 is equal to 0. It is given P1 is the plane passing through the intersection of these 2 planes and this point 2, 1, 3. And P2 is the plane passing through the intersection of these 2 planes and the point 0, 1, 2. Required to find the acute angle between the planes P1 and P2. We now discuss the solution of the problem in detail. And we know the equation of the plane passing through the intersection of 2 planes pi 1 and pi 2 is given by pi 1 plus lambda times pi 2. Now in our case, the equation of the plane passing through the intersection of the planes pi 1 is given by 5x plus 8y plus 13z minus 29 is equal to 0. Pi 2 is given by 8x minus 7y plus z minus 20 is equal to 0 is given by pi 1 plus lambda times pi 2. Pi 1 plus lambda times pi 2. Let's call this as the equation 1. And it is given P1 is the plane passing through the intersection of these 2 planes pi 1 and pi 2. And the point 2, minus 1, 3. So what you do is get into the equation 1, substitute x is equal to 2, y is equal to 1 and z is equal to 3 in it. Substitute in 1. So then it will be this one. Now simplify. You will get 28 minus 8 lambda is equal to 0 and this will give lambda is equal to 7 by 2. Then the equation 1 becomes pi 1 plus lambda 7 by 2 times pi 2. Agreed. Take the LCM and simplify. We will get 66x minus 33y plus 33z minus 198 is equal to 0. What we observe, 33 is common throughout. Therefore, cancelling 33, we get 2x minus y plus z minus 6 is equal to 0. This is the first plane, that is P1. There is a plane P1 given by 2x minus y plus z minus 6 is equal to 0. Similarly, we do the same thing for P2 with appropriate the given data, then we will get P2. That we do it in the next slide. Right. So we have pi 1 and pi 2. And the equation of the plane passing through the intersection of the planes is pi 1 plus lambda times pi 2. That is the equation 1 as in this slide 1. And P2 is the plane passing through the intersection of the planes pi 1 and pi 2 and the point 0, 1, 2. So get into the equation 1. Substitute for x is equal to 0, y is equal to 1, z is equal to 2 in the equation 1. Then we get this one. Then simplify. We get 5 minus 25 lambda is equal to 0. This will give rise to lambda is equal to 1 by 5. So get into the equation 1 and put lambda is equal to 1 by 5 and simplify. So pi 1 plus 1 by 5 times of pi 2 is equal to 0. And take the LCM and simplify. We will get 33x plus 33y plus 66z minus 165 is equal to 0. We observe 33 is common throughout. So cancelling that 33, we get x plus y plus 2z minus 5 is equal to 0. That's the equation of the plane pi P2. That is the equation of the plane P2. Right. Thus we got the equation of P1 and the equation of P2, and the acute angle between these two planes P1 and P2 can be found out, and we know that formula. We have P1 and P2, and we recall the acute angle theta between the planes P1 given by a1x plus b1y plus c1z plus d1 is equal to 0, and the plane P2 a2x plus b2y plus c2z plus d2 is equal to 0 is given by theta is equal to cos inverse modulus of a1 a2 plus b1 b2 plus c1 c2, the numerator, by, in the denominator, under the square root of a1 square plus b1 square plus c1 square into another square root of a2 square plus b2 square plus c2 square. Then the angle theta in our case is given by, so simply substitute in this formula. A1 is equal to 2, B1 is equal to minus 1, C1 is equal to 1, A2 is 1, B2 is 1, C2 is 2. Substitute this data in this one. Then you will get theta is equal to cos inverse of this one. Now simplify. The numerator will become 3. The denominator is root 6 multiplied by root 6. That is cos inverse of mod of 3 by root 6 into root 6. And 3 by root 6 into root 6 is 3 by 6. And the mod will go away. Cos inverse of 3 by 6 is 1 by 2. So cos inverse of 1 by 2, the acute angle we want. Therefore, it will be pi by 3. Agreed. So that is the, let's look at our options. And our answer, theta, the acute angle between the planes P1 and P2 is given by pi by 3. That appears against option A. Therefore, the answer to this question is option A. That is the detailed discussion of the solution of the given question, which is related to the angle between the given two planes from the three-dimensional geometry. And I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.